Hey guys, this is our first lesson on limits, which is the next unit we're going to study here in pre-cal. You can see by my outfit, it's casual Sunday. But I'm never casual about mathematics, so pay attention. This particular topic is vitally important because what we're learning now is technically the very first thing you would normally learn in calculus, which means if you're a junior or sophomore and you're about to take calculus next year, then this is you learning limits. And my guess is that the first time you guys study limits in calc, we will just do an incredibly brief review of this material. And that's because there's an expectation that you're going to remember the stuff that we're learning right now. So pay attention. Whatever notes you take right now, I recommend saving them so that you have them next year. But there's a couple of concepts here, really one big concept, which is the limit of a function at a point. So this is a picture of a function f of x. You can see f of x is defined by this line. All the points on that line are points that are in the function. Every point here is an x value, which corresponds to an f of x value. So it's like 1 corresponds to like 7 or something. When x is 1, f of x is 7. When x is 3, f of x is 2, maybe. But like this line here tells you, gives you all the f of x values, which correspond to all the x values in the domain of the function. We're going to start by talking about this with graphs. We're eventually going to talk about it analytically, which means where I just give you a function, like a formula for a function, and not a picture, and ask you to find the limit. But the basic idea is this. And this is really important. So the limit of a function at a point x exists if the limit as you approach that x value from the left of the function is equal to the limit as you approach that x value from the right. And from given a picture, this is what that looks like. If I want to know the limit of f of x, which is this graph, as x approaches 2, that x value, I trace the function as x approaches 2 from the left. So I start with small x values and I head towards 2 and I trace the function. So when x is like a half or something, that'd be right here. This is smaller than 2. So as I approach 2 from the left, you can see the x's are getting closer to 2. The y value is getting closer and closer to 4. So I would say the limit as x approaches 2 from the left of f of x is equal to 4. And that's because, I'm just going to repeat this because it's very important. As I approach 2 from the left, so it's like this, approaching from the left, the function, the y values on the function approach 4. Notice at no point here have I said what is the y value when x equals 4. I have not thought about that. It's not important to this problem at this point. The question is, as x approaches 2 from the left, which is what this notation means, x approaches 2 with a minus. I'm trying to write that a little better. This means the limit as x approaches 2 from the left of f of x. And what it means is take x values that are smaller than 2 and get closer and closer and closer to 2. Trace the function as f gets close to 2 from the left and see what f of x, which is the y value, see what that y value approaches. So here, the y values are getting smaller, 6, 5, and as f gets very, very close to 2, f of x, meaning y, gets very, very close to 4. So I would say for this function, the limit as x approaches 2 from the left of f of x is equal to 4. Now, the next question you would ask, what's the limit as x approaches 2 from the right of f of x? Well, it's a very similar procedure you go through. Now, since I'm approaching 2 from the right, I start with x values that are larger than 2, and I trace the function as I move, as x gets closer and closer to 2. So here, maybe x is 4, and then it's 3, and then it's getting close to 2. And so I look and I see, as x gets close to 2 from the right, what does f of x approach? That's the same thing as saying, as x approaches 2 from the right, what is the y value of the function approach? So I start here, when x is bigger than 2, and I move towards 2, going, it's from the right, so I'm going to the left. So I start from the right, and I go this way. You can see the y value, maybe here it's like 2 or 1, and then it's 3, and then it's approaching 4. So this limit is also 4. You notice that the function itself at x equals 2, there's like a jump. Like there's a hole, but it's defined up there. When x is 2, the function is defined to be equal to 6. We would say the function is not continuous when x equals 2, which means that there's like a jump. In this case, there's not a jump, there's like a hole. Because when x equals 2, you would expect the function, the y value to be 4, but instead it jumps up to 6. This is like, we would call this a removable discontinuity, but that terminology is not important. What is important is this. If I say, these are called one-sided limits, x approaches 2 from the left, x approaches 2 from the right. One-sided because it's only from the left and from the right. But, and this is the definition of a limit, if the limit as x approaches some value, in this case 2, from the left is equal to a number, and the limit of the function as x approaches that same value to from the right equals a number, and those numbers are the same, what this means in total is that the limit as x approaches 2 of f of x is equal to 4. So like if the limit as x approaches 2 from the left is 4, limit as x approaches 2 from the right is 4, then the limit as x approaches 2 is 4. But if the one-sided limits from the left and the right agree, that is what the limit is. That is the definition of a limit. Limit as x approaches some value of a function exists if and only if the left-hand limit and the right-hand limit exist and they are equal. So in this case, I would say the limit as x approaches 2 f of x is equal to 4 because the left-hand limit and the right-hand limit exist. Y'all are maybe you're going to ask me questions at some point, like there's going to be a question that's going to say, what's the limit as x approaches some value of a function? And you're going to be like, how do I find it? I'm going to tell you this every time. Approach that value from the left on the function, approach that value from the right on the function. If both of the if for each of those cases, the y value approaches the same number, the limit exists and it is equal to that. Just a side note here, the limit as x approaches 2 of f of x equals 4 for this graph. But f of 2 is equal to 6. What that means is that the limit as x approaches 2 and the actual value when x equals 2 may not be the same. In this case, they're not the same. And the reason I made this the first example is to emphasize the point that what happens at 2 does not affect the limit. Like the value of the function at 2 may or may not be equal to the limit. And as we do more examples, y'all will see more clearly the distinction there, but it's like very, very important. So our kind of, sort of rigorous definition of limit, which is the next slide on the first page, is this. You can say something like this: the limit of f of x as x approaches a value I'm going to call that value c. This is like any value c. And this first example, our c was 2, was that x approaches 2. The limit of f of x as x approaches a value of c exists if and only if the limit as x approaches c from the left of the function is equal to a number L. This is a number, not infinity, or this is like a real number. And the limit as x approaches c from the right of f of x is equal to L. And if this is true, then we say the limit as x approaches c of f of x is equal to L. So basically, the limit of a function as x approaches some value exists if the left-hand limit and the right-hand limit both exist and are equal to the same thing. It's possible they could exist and be equal to different numbers. It's possible that this one could exist and that one might not. The only time that the limit, this two-sided whole limit exists, the only time that's true is if the left-hand limit and the right-hand limit both exist and are equal to the same number. We use L there because the word limit starts with the letter L. The next slide says we have 3 main ways to find limits. We're really only going to look at 2 because the AP test really only tests 2. We might talk a little bit about the third one, but probably not. The first way is graphically, which is this. Like, I'll give you a picture, and I'll ask you find the limit as x approaches different values, and you just use the picture. And this technique where you kind of approach that value from both directions and see what the y approaches. So the first way, I would call that graphically. The second way, which I alluded to earlier, is analytically. Which means instead of giving you a picture, I'm going to give you like f of x equals and then some kind of a formula for the function. And that formula you're going to use to find limits, if possible. And the third way, which like I said, we may or may not really do, is numerically. Like I said, that's not usually tested specifically on the AP test, but it's helpful so you guys can see. It's like you can do it with the calculator, you can kind of get it. It's a good way to get your hands on the limits in a way that's harder otherwise. So that's your kind of intro. I'm going to do some of the practice problems that are in the notes, but I'm going to do them in a separate video because it's easier if I can write on the pictures. These pictures are kind of hard to draw on the whiteboard, and so I'm going to do those. In the next video, you really need to watch that. It's vitally important so that you guys can do that homework. All right.